everyone, myself Ron Singh and welcome back to my channel. So previously we covered all the 8 primitive data types, right? So in this video we'll be dealing with a concept called as typecasting in Java. Okay, so we'll see how do we perform the typecasting in Java and what is it. Okay, so let's get started. Yes, so basically with the name itself you can suggest that typecasting is something related to the casting of type, right? Yeah, so first let's see the definition for that. Typecasting means assigning variable or literal of one type to the variable of another type. Okay, I know won't be clear for now, right? Now let's just deal with let's just understand this scenario. Okay, so for example, as I said that assigning variable or literal of one type. So what are the types we have covered yet? Int, long and all that, right? So let's consider int and long. Okay, so assigning variable or literal of one type, this is a one type, to the variable of another type. Okay, this is something called as like this. Assigning variable means value of int to long or long to int. This is means this is just an example. Okay, you can take any other data type as well. Okay, so this is something called as typecasting. Okay, now the question is how do we perform this, right? We'll see this, but first we'll understand what it is actually, right? So for example, we are having two containers. Okay, one container like this, another container like this. So if I want to store one's content to another, and if I want to store another's content to this, then this is something called as typecasting. Okay, so basically there are two types of typecasting, but before that we'll first see what this point says. Okay, so this point says that only numeric to numeric casting is possible. Okay, which means we cannot cast to boolean. See the reason, because boolean can only have true or false, right? So we cannot have other values like 0, 1, 1000 or any such, right? That's the reason why we cannot cast to boolean, and we'll see this thing in practical, what happens that when we assign any other value to boolean. Okay, clear till now? Yeah, so as I said, basically there are two types of typecasting. Okay, one is implicit and another is explicit. Okay, so in this video we are emphasizing on the implicit one, and in our next video we'll be dealing with the explicit. Okay, so let's get started. Yeah, so as I said, there are two types of typecasting, right? One is implicit and another one is explicit, right? So first we'll see what is implicit typecasting. Now you know what is typecasting. It is like casting variable of one type to the another type, right? But now, as I said, there are two types like implicit and explicit typecasting. So first let's see implicit typecasting. So implicit typecasting means like casting smaller value or like smaller to larger. Okay, means smaller data type to the larger data type. Okay, so for example, I am having a small container and I am having a big container. Okay, so can I store this container inside this? Now you would say yes, easily, right? Okay, so now for example, in our example I have said that int. So what is the range of int, or I can say what is the memory consumption? 4 byte, right? And another is long. Okay, so long is 8 byte. So which one is bigger? Obviously long, right? And int is smaller, right? So now if I try to store this container inside this, which is if I try to cast int's value to long, can I do it? You would say easily, right? So if this stuff is going easily, means if you can perform any action easily, there is no need to write any extra code. Okay, so you can just say that int x is equals to 55 and you can just cast the value of x to long L. Okay, since long L is a bigger container and x is a smaller container like this. Yes, x is a smaller container, so you can just store this container over here easily, right? Just related with your real life scenario and it will be very easy. Okay, yes, so now as I said, this will be performed easily, so there is no extra code needed. Okay, like this. So this is something called as implicit typecasting. Okay, so for example, let's take another example as well. Yes, as I said, smaller to larger, right? So let's take an example of byte. Okay, byte to int. So is byte smaller? Exactly, because byte only consumes 1 byte and int 4 bytes, right? So now int is this, byte is this, right? So you can store the byte over here, right? Yes, you would say smoothly, right? So if this stuff is going smoothly, you can just say, means there is no need to write any extra codes, right? Yes, so for example, your first variable is 20, right? And now your int I is equals to b. As I said, you are casting b to I, right? So you are casting b to I in this way, right? So you can easily store 20 over here, right? Because int is a bigger container. Clear? So this is something called as implicit typecasting. Okay, now there is another way which is being used for calling the implicit typecasting. Okay, so implicit typecasting is often known as widening conversion. Okay, see, we are getting a scope wider, right, from smaller container to a bigger container. So you can just memorize this in this fashion. Okay, so if you are assigning smaller to larger, that is, you are getting widen. Okay, that's the reason why it is being called as widening conversion. Clear till now? Yeah, so let's do the practical stuff. Yes, so I'll just create an class. Let's name it as casting. Okay, yes, so let's create a main method. Okay, sorry. Yes, yeah, so now what I said, that implicit means smaller to a larger one, right? So let's take first as a int, right? And now if which is greater, means which is larger than the int, we can take it as long, right? So long as equals to a, right? Clear till now? If I want to print the value of both of them, how can I do that? I can just give the spacing. Okay, sorry. Yeah, see, it is coming out to be 45 plus, sorry, 45 space and 45, right? Because as I said, I am casting the value of int a to the long L, right? So in the memory there are two variables that are being declared, right? A and L. So a is giving this much space and L is giving this much space. So can I store this space inside this? You would say easily, right? So as I said, if the task is like carried out easily, then it is, there is no need to write any extra code, right? It is a cakewalk, right? So clear to all of you? Yes. So now let's take another example as well. As I said, byte b is equals to 45, or I can say 123, and int I is equals to b. Can I do that? Yes, because byte, again, byte got this, right? Means byte size is something like this and int size is something like this, right? So you can just store this over here easily, right? And as I said, if the task is carried out easily, then there is no need to perform any additional code, right? Means there is no need to write any additional code, right? So I can just say this out b and sorry and I, right? So now what will be the output? 123 space 123, right? The last line. See, clear? Yeah, so clear what is typecasting? Typecasting means casting one smaller container to a larger one, right? Just deal it with like a real world scenario and it will be more easier to understand. Okay, so small container means a data type that is smaller than the other one, right? And if it is smaller to the larger, then it is also called as widening conversion. Clear? Yes. Any doubts? Yes. So now, yes, so now the last point over here says that integer to floating point is implicit too. Okay, so what do we mean by this? See, integers, when we were dealing with the integer, what were the data types inside integer? Byte, short, int and long, right? And in the floating point, float and double. Okay, so if you are casting integers value to the floating point value, then it is implicit too. Okay, now you may encounter a question that since float is 4 byte, right? and long is 8 byte. How it could be implicit, right? Because you would be thinking like long is this and float is this, right? But it is wrong. See, when we were dealing with this data type, I said that long range is minus 2 power 63 to positive 2 power 63 minus 1, right? Yes, and the float range was something like minus 3.4 into 10 power 38, right? To positive, it was something like this, right? Yes. So this value is much greater than this value, right? So that's the reason why even if you cast long's value to the float, then also it is referred to as implicit, because float can hold much more value than long can. Okay, so that's the reason why if you try to cast from any integer to the floating point numbers, it will always be implicit, that is it will be always be easily carried out, so there is no need to write any extra code. Okay, now let's see this stuff also in practical. Okay, now what I'll do, the same example, long g is equals to, okay, sorry for this, 450, right? And I'll say float f is equals to g, and as I said, integer to floating point is implicit, so no need to write any extra codes, right? Yes. Now if I just run this, what will be the output? 450 space 450, right? See, but since float is an means floating point number, it will always convert this value to the floating point, that is 450.0. so if I just again give over here 451, then what will be the output? 451 space 451.0, right? Yeah, so clear? Yes. And now you know float is smaller than the double, because float is 4 byte and double is 8 byte, right? And the range of double is very much greater than the float, right? So if I say 45 or like something like this, right? Okay, let's take a decimal value, and if we are giving any decimal to float, we need to give the tailing f, right? Just a recap, double d is equals to x. Can I do this? Yes, right? And this is implicit, right? So now if I want to print the value of this, how can I do that? Sorry. Yes. Now what will be the output? 45.26 space 45.26, right? And since double is a, like we'll see this why it is coming out to be these values, because of the preciseness, and we'll see later when we move to the operands. Okay, means arithmetic operations. Okay, so don't worry about for this. Okay, yes. So as I said that integer to floating point is implicit too, and we saw this example, right? Long is a type of integer, right? And I can also give int, right? And I can also give byte as well, because all of them are integers, right? See, again it is 451 space 451.0, right? So as I said that integer to floating point is implicit, so no need to write any extra codes, right? Yeah, so let's discuss the size. Byte 1 byte, right? Short 2 byte, int 4 byte, long much greater than this, right? 8 byte. Now float is again this one, right? And the double is the greatest among them, right? So it will be like byte to short, short to int, into long, and long to float, and float to double, right? So let's see the chart for this. See, okay, yeah. So now, yes, so now as I said, byte is 1 byte, right? That is 8 bit. Short is 2 byte, int is 4, long is 8. So all of these are integers, right? And these are floating points, right? This is again 4 byte and 8 byte, but the range is much greater than this one, right? So these are floating points, right? Yeah, and as I said, integer to floating point is implicit too, right? So this will be carried out very easily, right? And now char, the only data type that was remaining is char, right? So char is again 2 byte, so you can cast it to any one greater than this, right? Yeah, so if you cast any of this value, means if you cast byte to double, even then it will be easier, right? Because since byte is the smallest one, it can be get accumulated to any one of them, right? Yes. So now let's see this one as well in practical. Yes. So for example, as I said, char C is equals to, inside the single quote, capital letter A, right? And now I'll say that int y is equals to C. Now what will be the output? See, now first I'll just write this is out, and we saw this actually when we were dealing with int and char, okay? But now let's just quickly recap that. See, as I said, char A, but whenever if you want to assign this value to int, then this will be fetching the ASCII chart, right? So it will be coming out to be something like 65, right? Let's see that. Okay, so for example, if I just now print this, okay, see, A space 65, because char is C, and means C is a char, and the value for char is A, but for y cannot hold the char, but it can hold the ASCII value of that respective character, right? So the ASCII value for capital letter A is 65. That's the reason why it is coming out to be 65. Okay, so clear to everyone? Yes. And if I say float over here, see, again it's fetching the ASCII value and it is coming out to be 65, but since float is a floating point number, it just converts it to a decimal, that is 65.0. Clear to everyone? Yes. So we discussed what is implicit typecasting, right? Means casting from smaller data type to larger data type, and it is often called as widening conversion. Don't forget this name, okay? Because this is the only name that is referred to for calling the implicit casting, okay? Sometime means it is most oftenly called as widening conversion only, okay? So don't get confused, it is same as, means it is nothing but this implicit typecasting only, okay? So what was the flow? Byte, okay, we can just say byte, that was 1, right, to short, to int, to long, to float, and to double, right? Yeah. And char was again 2 byte, right? So short and char was 2 byte, and int was 4 byte, long was 8 byte, float again 4 byte, and double 8 byte, right? So see, these are floating point, these 4 are integer. So as I said, integer to floating point are implicit, and char, since it is 2 byte, so if you just give a 2 byte value to any other value that is greater than it, it will be easily acquainted to it, right? So that's the reason why it is again implicit 2. So clear? Yes. So any doubts? Yes. So guys, if you have any doubts, you can just ask me, or means while by commenting your doubt in the comment section, or you can just reach out to me on my Gmail, okay? And I have also give the links for my Telegram or WhatsApp in my channel description, okay? Yeah. So thank you so much for watching the video, and in our next video we'll be dealing with the explicit typecasting, okay? So thank you so much.